Alrighty guys, so here's the next video. This is going to be a little bit more in depth, so get ready to write some good notes today. We're basically taking and just blasting off from where we talked about on the last set of notes, where we talked about exponents and how those exponents could be rationals, and we needed to have just a small foundation for when we moved on to here. So let's go ahead and take a look at some more rules of how we deal with these exponents, and then that of course would change and affect how we would look at our powers if they were rational. So the product of powers, okay? So the product of powers, what it's trying to say is that if I have a to the m power and I multiply it by a to the n power, that's going to give me a m plus n. So key things to look at is that you'll notice here for the product of powers to work, a has to be the same number. So it has to be an x. They both have to be x, or they both have to be a 2 or a 1. Like a has to be the same variable or the same number. M and n, you can see they could be different, but what we do notice about them is we add them together, okay? Now the quotient of powers, what that's going to do is say we had a to the m power again, but now we divide it by a to the n power. That then translates into us doing a m minus n. So now notice we're now subtracting here. So with multiplication we have addition. With division we have subtraction. So we're going to take m minus the n. You cannot flip it and do the n minus the m, okay? That's the idea, is you got to do m minus n. Now the power of a power, okay? So what that means is we have our a to the m power again. But now let's say we take this same expression and then we raise it to the n power, and I know that was a terrible n power. That means we're going to go ahead and multiply them together, okay? So I've covered all the basics. When you have multiplication, okay, you add. When you have division, you subtract. When you raise an exponent to another exponent, you multiply, okay? Basically covered the trio here, okay? Now let's keep going and expand on this idea. So we now have the negative exponent. Okay, now I mentioned this in that first video. That's when you have a term, and actually let me go back to my green. When you have a term and you have a to the negative m, that means you have to go ahead and place him now in the denominator. Now it could also be said for vice versa. If you had a to the negative m but in the denominator, you would move him back up to the numerator, okay? Now the zero exponent, this one is super easy but totally trips up everybody known to man. If you have a to the 0 power, it does not matter what a is. It doesn't matter. It's going to be 1, okay? Anything to the 0 power is 1. Very fun fact. Power of a product, okay? So say if I had a and then b, and I was multiplying two terms here, so like 2 times 4. Okay, I was doing 2 times 4. But I had them raised to the m power. That translates into me doing a to the m, b to the m. So you'll notice that m distributes itself to both of these values right here, okay? That's what it's doing there. Now, the power of a quotient, okay, that's going to be a divided by b raised to the m power, okay? And yes, you guessed it, it gets distributed to both. So we have a to the m, that looked like a squiggle, there we go, and then b to the m, okay? So what you have here is all the properties that we're going to be using in this video. And so now let's go ahead and perform examples, and so that way we can actually apply these definitions and these properties, okay? So give me 1 second to switch over to that. I'm going to get rid of this. There we go, just scooted it up. So let's first start off with the product of powers. Okay, so let's do that. So let's do product of powers. Alrighty. So say I had something like 7 to the 1/4 times 7 to the 1/2. So now we have those rational exponents again. But the reason we can use product of powers here is because we have the same a value, okay? They're both a 7. The m and the n, this is my m, this is my n, right? So just keep that in mind. Now, what we then do, though, is we add these expressions together. So we have 7 to the 1/4 plus 1/2. Now, you guys should be pros at adding fractions together by now, okay? That should give you 7 to the 3/4, okay? And there you go. That's your answer. Let's do another one. Let's say we have 2 to the 3/4, and then I have times 2 to the 1/2. Okay, once again, a values are the same. We can go ahead and add the exponents. So I've got 2 to the 3/4, and then I add the half. That gives me 2 to the 5/4. Okay, there you go. Voila! So there is the product of powers. Now let's talk about the quotient of powers. All right, there we go. Let's put the title there. Boom. Alrighty, so example for this one is we have 4 to the 5/2 divided by 4 to the 1/2. So remember, when we're doing division, we end up doing subtraction. So this actually looks a lot scarier than it actually is, because if you do 5/2 minus 1/2, then that just comes out to 4 over 2, right? So you have 4 to the 4 over 2. Now what's 4 divided by 2? We could simplify that. That's just 4 squared. So in truth, our answer is 16. Cool. Who would have thought that would have been 16 right there, right? All right, now let's do another example. Let's say I have 5 over 5 to the 1/3. Now, please make sure you understand that we're able to do the quotient of powers because the a value is the same. So please be aware of that. They have to both be 4s or both be 5s, okay? Or something like that. Now, looking at this right here, if you were to do some subtraction, you might be wondering, what in the world is this top one? Like, what's his exponent? Well, remember, it's a 1, right? And so you would end up with 5, 1 minus 1/3, okay? Now, 1 minus 1/3, what is that going to give us? Well, 5 2/3 is what I'm thinking, right? And there you go. Now let's do one more. Let me see here. Let's do... Oh, I guess I can do that one later. Yeah, I'll probably hold off later. Let's go ahead. Let's jump over to the power of a power now. All right, there we go. So now we have power of a power. So that right there is when you have something like 3 to the 5/2, but now we raise this 5/2 to like a 2. So what that means is we're going to do multiplication. So we have 3 to the 5/2 times 2. Now, that's going to simplify because these 2's are going to divide out to 1, giving us 3 to the 5th power. And 3 to the 5th power, we could simplify that nice and easy to 243. Now, another one we could do is 12 squared. And let's raise him to the 1/4 power, okay? So that would give us 12, 2 times 1/4. That ends up being 12 2 over 4, which that could simplify to 12 to the 1/2 power. And then you're done. Okay, so that's power of a power. Let's go ahead and take a look at a negative exponent, and then I'll try to mix some together so you can see how they all interact. Alrighty, so here's a negative exponent. So a negative exponent looks like this. If you have 36 to the negative 1/2, remember all that means you're going to do is you're going to take that value and you're now going to put him in the denominator. And then, of course, we could actually simplify this because you can actually do the square root of 36. That would end up giving you 1 over plus or minus your 6, right? So you could simplify that out. Another idea, though, that I want to drive home is that say you had 1 over like 3 to the negative 1/3 power. You would actually need to flip him to the top to make him positive. So that negative exponent rule, not only is it good for moving things to the denominator, but if something's negative in the denominator, you can move it to the numerator, okay? So just be aware of that, okay? Now let's go ahead and mix this up so that way you can see it all interacting with each other. Truthfully, this is my favorite part, is the mixing, because it's where we actually get to do some fun math here. So let's say we have this. I have 8 to the 2/3 times 8 to the 1/4, and then let's raise all this to the 12th power, okay? So the first thing we need to address is what's inside the parentheses, okay? Looking at this right here, we need to go ahead and add this together because the a values are the same. So we have to the 2/3 plus 1/4, okay? Now, we could add that together real quick, or we could just do some math here. I guess let's make the denominators the same. So in order to have the same denominator on the bottom, they have to be a 12, right? So that means I need to multiply him by a 4, multiply him by a 4. So that means I have my 8, and then I've got 8 over 12, plus, and then I got to multiply them by 3, him by 3. So then I have 3 over 12. There we go. And then this, of course, is still to the 12th power. And actually, me doing that actually makes more sense now because something's going to simplify in just a little bit. So what's 8 plus 3? Well, that gives me 11, right? So that means I have 8 to the 11 over 12 raised to the 12. Now, remember, now this is a power of a power, so that means I need to go ahead and do 8, 11 over 12 times 12. Now, conveniently, those simplify, leaving you with 8 to the 11th power, which is a massive number, I bet. Okay, so that is mixing it up a little bit. Let's do another mixing. Let's try this one. Let's do 7 to the 1/5 power divided by 7 and then squared. So this right here, the first thing we have to do is we have to do the quotient property, okay? And yeah, the quotient of powers. And what that's going to make me do or require me is to subtract. So I have 7 to the 1/5 minus 1, right? 7 to the 1/5 minus 1, and then this is all squared. Now, we need to go ahead and convert the 1, so that's going to give me a 1/5 minus 5 over 5, right? Now, 1/5 minus 5 over 5 is going to be 4, right? 7 to the negative 4/5. Now, this right here, okay, we're going to go ahead and multiply real quick. So it gives me 7, and then I have negative 4/5 times 2. Now, negative 4 times 2 is negative 8, so that means I've got 7 to the negative 8 fifths, right? Now, since this is a negative right here, I need to use that property where I move it down to the bottom. Does anybody remember what it's called? You didn't think I'd ask you a question in this, did you? Right, whoever said the negative exponent rule is correct, okay? The negative exponent rule is when you have 1 over 7 8 fifths, okay? Boom. All right, let's do another example. Next example, let's do, I think this will be our last one. 9 to the third times 9 squared to the negative 1/4. So we got to add, so I've got 3 plus 2 to negative 1/4. That gives me 9 to the 5th to negative 1/4. I multiply. That gives me 9 to the negative 5/4. And then, of course, I bring it down to the bottom. Easy peasy, right? Some of you are like, no, Mr. Farmer. But hopefully this will get easier in time. We'll be doing examples and practice with the homework. So please make sure you let me know if you need anything. Alrighty, let's go ahead and take a look at the other properties. Alrighty, so the next one on the agenda is the zero product, or the zero exponent one, sorry. So say I gave you something like this, 213 x to the 73, y to the 58, and then I have 800 x to the 15, and then y to the 32, and then 0 power. So looking at this right here, this can look very intimidating, but guys, this is actually really easy. This is all equal to just 1. Because anything raised to the 0 power, it doesn't matter what's up in here. It's all going to go to 1 because of that guy right there, because of that 0. So it doesn't matter what it is. You could have just 213 to the 0 power, and that's still 1. So just keep that in mind, okay? Alrighty, let's go on to the next one. So the next one is the power of a product, okay? Power of product. So power of a product is when you have something like 16 times 9. Ooh, terrible. Times 9. There we go. Raised to the 1/2. So what you got to go ahead and do is you got to distribute that exponent. So you have 16 to the 1/2, and then you have 9 to the 1/2. But we should be comfortable with solving that because you know how to convert that now, especially from the first video. That's going to give you 4 times 3 because the square root of 16 is 4. The square root of 9 is 3. And so that would give you 12, right? That would give you 12. Now, looking at this next one, let's do power of a quotient because let's finish this up. So I've got myself a 27 over 64, and I have it to the 1/3. That means you got to distribute that 1/3, so you have 27 to the 1/3, and then 64 to the 1/3. That's going to go ahead and give you 3 over 4. Because if you do the cube root of 27, that's 3, and the cube root of 64 is 4. Okay. Alrighty, guys. That's it for this video. If you need more examples or need more help, please let me know. I will go ahead and make sure to post more videos, and also please stay updated on the homeworks. The calendar is there available to you in the online information to give you some more direction and be able to make sure that you're staying on track with this online Algebra 2 course. Always here to help, guys. Miss y'all. Take care.